Hello, today we are graphing piecewise functions. Um, you should print out the graphing piecewise functions handout that I have a copy of here. And I will work the first one first, then I'll ask you to pause and try the second one, then I will work the second one, and so on and so forth. Let's first talk about this first one. About what it means to be a piecewise defined function. A piecewise defined function is called that because it's defined by different equations for different pieces of the domain. So this domain of this function is broken into three separate pieces. If x is less than or equal to -2, if x is between -2 and 6, possibly equal to 6, or if x is greater than 6. So those are three separate pieces of the domain. On that first piece, when x is less than or equal to -2, this function is defined by the equation y equals -x minus 3. So now I'm going to get a ruler, and let's see, the line y equals -x minus 3 would have a slope of -1, a y-intercept of -3. So this is what the line y equals -3 would look like. I know you can probably barely see that, but that's on purpose because we don't want this entire line. We only want the part where x is less than or equal to -2. So I'm going to take my bold pen. I'm going to bring my ruler back in here. And I'm going to make the part of the line that I do want nice and big and bold. Now, when you're graphing just normal lines, very frequently people will omit the arrows on the ends. But since piecewise functions don't always go forever, we can't assume that that's how people will interpret a graph. Well, we don't want people to interpret the graph that way unless we actually draw the arrow. So the arrows are very important. The other thing that I want to look at now is how to mark this endpoint. So my graph has gone, it's going to stop here. But I want to look up in here and notice that it actually is going to include the point -2 in this piece of the domain. So I will use a solid dot, just the way that when we were graphing on the number line, we used a solid dot to indicate when a point was included in the graph. So now let's look at the next piece of the domain. Between -2 and 6 is going to be defined by this function, this 1/2 x plus 5. So I'll have a y-intercept of 5 and a slope of 1/2. And I'm going to very lightly draw in this line. So now I don't want this entire line. I only want the part in between -2 and 6. So I'm going to take this again. So -2 is there, 6, 2, 4, 6 is there, and I'm going to make this part of the graph nice and bold. Now I'm going to look at my endpoints. On this end, I have a strictly less than. There is no or equal to. So this will get an open circle. On this end, I have a less than or equal to. So this one will get a solid dot. And there is my middle piece. Now finally, I've got this last piece for when x is greater than 6. I'm defined by the function y equals x minus 6. So that would have a y-intercept of negative 6, a slope of positive 1. Oops, make that right. Sketch that in lightly. Now the part of this that I want is when x is greater than 6. So I'm going to make that part of the graph nice and bold. Here on this end, this is a strict inequality, so that point is not included. And on this end of my piece, I want to indicate that this graph does keep going. It's everything greater than 6. So I put an arrowhead on that end. Now you can still faintly see the little traces of my lines, of my helper lines that I drew. And I'm going to go in now and erase those helper lines because those are not part of the function. I only drew them to help me know where to draw my functions. And if you have the skills to not draw helper lines when you're graphing piecewise functions, that's fine. As long as you have your pieces graphed correctly. Alright, so here's where you should hit pause and go and try to do number 2 on your own, and then come back and unpause the video after you've given it your good attempt. So pause now and come back. Alright, so now we'll assume that you're coming back. I am going to start similarly. Here are my 3 pieces. This first piece is defined by the equation y equals 1/3 x plus 4. So a y-intercept of 4 and a slope of 1/3. Now I only want that for x less than negative 3. So I'll come in here and make that part of this line nice and bold. This end keeps going in this direction because it's everything less than negative 3. And since it's a strict inequality, it does not actually include the point negative 3, so I'll draw an open circle right there. So next, I've got the absolute value of x. Now your absolute value function has 2 arms. The left arm has a slope of negative 1. The right arm has a slope of positive 1. So this is what I'm going to use. Now I want between negative 3 and positive 3. So I'll go ahead and graph this in. Could have straighter lines if I used my ruler, but that's good enough. Now let's look at our endpoints. This is a less than or equal to, so this dot needs to be a solid dot. Notice that my solid dot landed on top of my open dot. That is absolutely fine. It just fills in that circle. A solid dot will always trump an open dot, no matter which one gets graphed first. The solid dot means that that function is actually defined there. And so on this side, I need a solid dot as well because this is less than or equal to positive 3. And finally, my last piece, this is the graph of y equals 3, which is a horizontal line with a y-coordinate of 3. And so, and really this one, maybe we could do this without the helper line. So now this is a strict inequality, and I would draw an open circle, but notice that it would land right on top of that closed circle. So that function is already defined there, and I can leave it just the way it is. And then I do need to draw an arrow on that end. So now I'm going to clean up my graph by erasing my helper lines. You may want to erase your helper lines after drawing each piece. That's up to you. But they should not remain on your final answer. So there is graph number 2. So go ahead and do number 3. Pause the video and come back when you're ready to see the solution.